Okay, so this is the code that we look at.
The right part has to connect to the right part of the graph. So that you can guess this is a fully connected graph.
Everything okay?
Yeah.
All right, all right. I thought my computer is generating those sounds. Okay, so this is the code that we presented before we say goodbye on Friday. So this is code. It's very simple, but I want you to pay attention not just about the syntax, but more important about the style that we actually programming this way to help to support object-oriented, because the function we try to do here is to try to dump the content of an object. That's why, let me actually make it a little bit bigger. We can see that a person object has a name, has a social security number, has a home address, and has a bunch of other things. And then, as you can imagine, we're going to extend it. When you extend the person, try to include more perspective about this person, then the information that contains the person object could be more and more complicated. Therefore, we really want to make sure that we have a way to do it very elegantly, to be able to say, dump it out, print it out, or have some way to organize the information so we will be able to see that what's going on within each of the objects. Here, there is I said it's an important concept, is that when I talk about the dump for a person, meaning that I'm not talking about dump a person, I'm talking about dump the information from the software engineering perspective. And you can see that I'm actually not including all the logic within this small piece of code, but instead I rely on other piece of code to help me to accomplish the mission. So you can see that the example I show you is that when I dump what we call basic type, the basic type is such a name is a string, so I just print out as a string, that's fine. But if this is a home, which is another object, which is a GPS object, then I'm actually not going to be construct a dumper in person object about the information about another object. But instead, what I did is I just basically called the dump in that object. So essentially, you're thinking about this actually happened a lot in object-oriented programming, is that I separate the functionality, the operation of what we want to accomplish into the best place, or the place should know that information the best. So you think about, here is a person, and the other object is GPS. GPS and person, who actually know the dump of GPS information better? The person or GPS, obviously, is a GPS. So we kind of cluster or group the operator, the method, the algorithm closer or closest to the object that's actually really going to contain those information. So that's the general spirit. So when you design the object-oriented, you not only think about information, you think about code as well. You think about the program you need to associate with that. And that's the way we actually look at this. So you can see that I do dump the information person and dump. And let's try to run this program to see how it looks like now. Okay, so after I done this project, and I just say test. Okay, now let's take a look at the output. The output is I have the name, and I have the SSN, and then I have the home, but the home actually call the dump for the GPS location. That's why I actually go to GPS DD, and then I dump the latitude and longitude for that particular location. And that's the second part is actually the dump for the thing. So you can see that a dump is actually a function. And in fact, you can see that I have other things I need to dump, but I didn't have it. So this is actually a print out function. So you basically be able to show it to people what's the content of this object. All right. So before I move on to the next more complicated example, can you actually tell me if you have any question regarding this simple piece of code? Yes, please.
So this home.dump is going to call on a different piece of code to dump whatever information is related
Right.
to home, right?
Right.
Is that information in GPS.h or is it somewhere else?
Yes, it is in GPS.h and GPS.cpp.
Okay.
So first, that's an excellent question. So when we say this to the home is an attribute about a person. What's the type of home? It's GPS.dd, right? Let's actually take a look. So if you control accept to person.h, and you can see that here is home. This attribute called home. And what's the data type or object type for that home is GPS.dd. So when I call this to the home, I'm really referring to an object under GPS.dd. So now let's go to GPS.dd. Okay, this is GPS.dd, and then you can see that over here, I have a function called dump. So essentially, I just want to tell you, I actually place this function dump on every single class I define. If I can homogeneously provide this interface, but even though their function name is the same, but the class type is different and the information is different, and then I'm actually going to GPS.cpp, which is the code is really implemented, is here. You see, this is GPS.dd dump. Over here, that's actually the specific version about the code that's actually dumping the GPS information. That's how we actually, what I meant is instead of in one piece of code, try to dump everything, I kind of separate code to push them closer to where the data really is. Okay, that's very important because we usually think, okay, here's the code, here's the data. We're dealing with this. But in object-oriented, we try to actually bring the data closer to the code. And we try to class them together as a concept called class. And that's actually very powerful. It's not just say, it's clear about one particular class. But in this case, you can see that it's actually very nice to support the same similar operation for other class. In this case, dump is also a function in person, which GPS is a component of the person. So therefore, it's actually very easy for me to write the code like what I showed you earlier. So that's why let's actually just compare this two pieces of code. They're both dump. The top of the window is the dump for the GPS information, which is defined as part of the class GPS. The below is dump that associate with a person class. And that is essentially included in the definition and implementation of class person. It's a very simple example, but you can actually extend this concept you learn and design really elegant class. You can think about that. Later, you will see that when the object is getting really, really complicated, and I actually have a way to actually organize this information very elegantly using this very simple principle. Yes, please, in the back, please. Right. Here, right. Right. Okay, okay. Good question. So I don't know when I want to really introduce the full concept of pointer, but right now let me just tell you enough. You don't have to write the code, just understand the code. So this piece of code, in fact, if I remove this hyphen greater than, the code will behave exactly the same. So that one is actually a bit redundancy. And the reason I actually put that this is a convention to be explicitly tell the reader of the code that this is actually, we're talking about an attribute in this particular class. Okay, if I actually, let me actually put it this way. If I remove this, okay, let me just contrast. If I remove this home, and I actually define another place, I call it, let me just say, I call it something called person home. Okay, and the thing is that we might confuse, the compiler might pick up, say, hey, there was a conflict. Let's try to, whether this code will even compile, okay? Let's see if the code, I actually haven't tried that, but I want to actually try it. Yeah, it compiled. So essentially, so I was right, actually. Well, I should buy a lottery today. I got right occasionally. Okay, so you can see that I actually have, I can actually define a local variable with exactly the same name as the class member. And the thing is that when I do home dump, this home, because this is the closest one in the same scope, this home will be binded to this one. It's become a person dump instead of being a GPS dump. So that's why if I say this to the home, there's no ambiguity. That's why I always use this. You can see that it's really not necessary for that particular case. But if you actually make this kind of mistake, by the way, this is horrible. This is horrible that you actually define an attribute in a member function that's the same as the member. That's actually very bad. This is called local variable. And this to the home is actually a member attribute of a class. So that's a bad mistake. That's why to avoid that, we actually do this. We do this. And I usually cast it to actually say this is the pointer to object. That's what we're talking about right now. So this is actually a good lesson. I want to thank you for your question. The other thing I do want to tell you that this is also a convention, that there are two conventions to actually differentiate whether it's a local variable, so my convention, this is just, if you look at some of my code, I always do an LV, local variable. I just say that I don't care whether it's a home or ball, I do always add LV underscore to actually represent that is a local variable, just for me to be able to read my code more clearly and won't make that kind of mistake. Okay. All right, you have a question? Yeah, please. Oh, okay. This is actually in C++. This is called string, IO string. So this means that it's always pushed that way. This is a more elegant way of doing printf. So you probably use the library function called printf, try to print it out. So essentially, this basically say, hey, you're going to send your output to cout. Cout is an output device. And the first thing you're going to send out is this string. And then the second part is this. So essentially, this is like a printf with a format string like this one, and this one. So this is just separation, go that way. You can go this way as well, just cin and cout. That's just a different interface. Hang the back. Yeah, you can do that. You can do both. Yeah. If you do this home, it will always, you took away this, and then you have only home. No, it will just use this one. It will just bind it with that one. Yeah.
So in that case, would it just print the same information twice? Because it does name, SSN, and then home.
Right, it will. Oh, I guess what you're saying. Yeah. Oh, you're right, you're right. It will infinite. Yeah, you're right. I never tried. I think it will actually. It will. Okay, I never thought about this. This is actually double that. Okay, thank you. Yeah, I got it. Yeah. Okay, this is a dump. This is home as well. Yeah. This is a infinite loop here. All right, thank you. Yeah, go ahead.
All right, one more question. If you had done this location dot dump instead of this home dot dump, would it output the same thing because home and location are both part of GPS DD? So they just input whatever GPS DD dump function says to dump, right?
Say it again. You say which one?
If you say this location instead of this home
Right.
dot dump, would it output the same thing?
It will. It might not. It might not. It's the format is the same, but the output value is not the same. So let's look at this. Let me actually. This is fine. If you go to person.cpp, right? The person.cpp, oh, not person.cpp, person.h. You see, I have a two variable, right? I have a home and location, right? And the thing is that I actually call the function to set that differently. So they're going to call the same function, but the value is going to be different. Yeah, we'll see example like that. Okay. All right, I'm going to move to show you a different style. All right, so that one I showed you is just basically print out something. But sometimes I not only want to print out, I want to actually process that information in the way of the dump. So let me actually show you. This is the code. If you download it from the GitHub, you can actually already try it. So I'm going to make it. And I'm actually going to run the program. So, okay, now you can see that I'm actually printing out essentially the equivalent information, but I'm actually using a new concept called JSON, data exchange format. So JSON stands for Java script object notation, which is extremely useful, valuable. I'm going to teach you in detail. But here, I want to show you that this first part. So instead of trying to print out, this is essentially the person part that I print out. You can see that the first thing I print out is SSN. In fact, the way JSON organize the information, they just show it in alphabetical order, but internally, there is no particular order. So you can see that the first attribute is SSN, the social security number. The second one is a name, is a home, which is the GPS location with the latitude and longitude. And the third thing is a location related to your question. You can see that it's a different location. They're very close to each other. I think one is IKEA, one is Costco. And the home and location, and then name is Felix, and since when I have a timestamp adding over there. Okay, and then I also dumped the second one, which is the thing. The thing was the Swedish meatball. If you look at the code last time, there was a thing called Swedish meatball, and then basically it has all kind of information. It has the description, location, which is IKEA, and then you have the model. That was the whatever I Googled it. I love the Swedish meatball, just like you know. And this is actually the owner, the person, because I purchased it. I purchased that, so now I'm the owner of that thing. And then it's a purchase at this time, there's a sequence number, and then I purchased, maybe I sold it to one of you, I don't like it, and then I resold it, assuming that that's actually valid. I probably picked the wrong word. And then there's a time. So this basically purchase and sold represent the time period I possess this particular thing. Okay, so you can see that it's the same information, but now I'm going to using this format called JSON. And I'm actually going to show you the code of a JSON, which is similar to what you actually see that. So let's actually go to GPS. GPS.h. So this is the code we have. The only thing is different is this one. Now I have a dump. I actually changed the dump to be a function I call dump to JSON because I want to dump it to a JSON format. And so what happened is that instead of dump to a dump to the standard output, which is your monitor, I'm actually dumped to another class or another object called JSON colon value. So I want to tell you, this is probably the first time or second time you see this notation. You see that there is a JSON, and then there is a colon, and then there is a value, right? So what did you see this before? You actually see when I say std colon cout, right? Namespace. Okay, this is a namespace. So there is a whole namespace called JSON namespace. JSON colon value. So that one is already being defined. So I'm actually, you don't have to do anything. It's already there. It's already implemented. So that's why in the trick I have for in order to use the JSON namespace, I actually need to include those 4 lines. Those 4 lines of code, which is include the library, so I can actually use the JSON. All right, so that's the definition of a JSON. I declare this function. Now instead of dump to just output, I can't do anything about it. Now I have to dump it to a JSON object, and I include those 4 lines, and everything is done. Okay, let's actually look at the GPS.cpp and see how it works. I want you to think about that. Compare this two approach. One is using printf or cout. One is using JSON. Which one do you think is actually more complicated or easier or things like that? So let's look at GPS.cpp. And this is actually at the end. Okay, this is, let me actually make it one window. Okay, this is the code that I developed for the dump. So you can see that what I did is I actually checked. So this I actually did a check. I checked whether the latitude is a 0.0. That means I never set the value. If I never set the value, I decide not to do it. This is actually irrelevant to the dump, depending on the semantic application you want to perform that check or not. I mean, the previous one, I just didn't do the check, but this one, I actually check it. So look at what I did. I first declare an object called JSON value, which is the one I'm going to return. It's called result. So I create a empty blank JSON object. This is maybe the first JSON object you ever seen. And then if there's a latitude, see what I did. In JSON, I just say result. And then with this bracket, looks like it's an array. And then inside that array, I put a string, double quote string. And then I said it's equal to this to the latitude. That's it. And then I do the same thing, say result longitude and this to the longitude. And then what I did is I just returned the result. By the way, this is just a debugging line. You don't have to, but this one actually will print out the content about a JSON using a particular library function called toStyleString. But you don't have to worry about that today. It's just saying that it's so easy to use JSON. It's just create an empty JSON object, C++ JSON object, and then just use the way, just like using array, double quote, and then put that, and then when you do this, you're actually going to generate the output looks like this one. You see, that's how you actually generate. This is, by the way, it's called key value pair. What's JSON? Okay, let me actually I want to say one thing before I tell you what JSON really is, because I know many of you have never seen JSON before. Okay, any question about the code I just showed you? I just want to ask you this question before I move forward, because this is actually my connection to the next chapter. Have you actually ever seen this kind of syntax before? Result, and you put something other than a integer or index. Dictionary, right? You can put dictionary. What other situation? Can you put a double? Can you put actually something else, like a double? You actually put anything you want over there.
Except objects, right?
You can actually put object. You can. You probably can put object as well. Because that is actually what we call operator overloading. So the basic C++ only have a bracket, which is including the index. But now C++ offers something called operator overload. So what is operator? Operator plus is operator, multiplication is operator, array is operator as well. So I want to overload the meaning of original operator, including the data type, to actually have that. So I want to show you this only because I want to lead to the next chapter after I talk about a few other things. But that's actually what we're going to start looking at in chapter 12. It's really powerful. You can actually design all kinds of things you want. Okay, all right. Now I'm actually going to tell you what JSON. What is JSON? This one. Okay. First, I should actually tell you that JSON is a C++ library. It's kind of library that you can actually use. It's not really part of the language, but you leverage a lot of nice language feature in order to accomplish. And what JSON is really a way to representing an objects. So, so representation of the object is actually very critical. So you already learned a little bit about C++, how C++ allow us to define a class. But until you hit homework assignment number 4, you won't get a chance to actually really seeing in memory about how those objects are being stored in your memory when you actually run the program. When you look at, especially when we look at the difference between what we call virtual inheritance and multiple inheritance, then you will see the representation object is really critical in that sense. Okay, so JSON is another way for us to represent an object. And I will call this representation universal. Universal means that any object-oriented language, their object, I can actually use JSON to represent. So you have a C++ object, I can represent you using JSON. If you have a Java object or Python object or Ruby object, whatever object-oriented language you have, I can actually be able to represent your object using JSON. And by the way, how do I actually get that? You actually already see that. What I did is I dumped the object. When I say dump to JSON, what I really accomplished is I actually changed the object representation from C++. I don't know why it is because you haven't done your homework assignment number 4. I can tell you it's very ugly in advance, but I actually can output to a JSON format I just showed you. And what's important about this, just give you an example. There's a lot of good things you can do. So now I can actually make a C++ code talk to Python. Because now I actually have an object in C++, and I have an object in Python. How do they actually be able to talk to each other? Very easy. I actually convert that object into JSON. And then from the other way, I actually convert that JSON back to Python. Now I can actually use my Python code to interact with that. So this kind of object representation in object-oriented programming is actually very important. Even though this course is about C++, we're really learning the general principle about object-oriented programming in any language, which is really the industry is doing. I mean, if you go to any of the company industry, you actually don't know what language they're using. So having this capability to understand that is important. By the way, if you think about any big company that using internet, they're probably 100%, they're using JSON, either 100% or partially. Because why? Because it's so easy to do that. Okay, so what is a JSON? The JSON is actually, syntactically is a very, very simple. It's just have a few symbol, has a curly bracket, and then has this double quote with that colon in the middle. It's just using what we call key value pair. So in this sense, you can actually see that the JSON value is the first key and the first value, the second key and the second value, and so on. And that's how you represent that. Of course, you can actually have a more complicated, for example, you could have an array. And that's another complicated thing about JSON. Other than that, there's no more. So you have a curly bracket, you have a comma, you have a colon. The other one you have is bracket. This bracket represents array, a collection. So it means that this represents array. So if you have you can represent array, you can represent object, you can represent basic type. That's pretty much everything you can represent as object is there. So for example, Facebook use JSON to represent all the information they transfer to you when you use Facebook. And just tell you that this is a Facebook API. When you look at your API, they essentially look at, for example, how do I actually represent all the likes? If somebody say, hey, you like, there's 2 million likes, and you want to represent and then download to your browser, how do I represent all the likes? I'm using array. I basically have a data, and basically the count says how many likes you have. So the count represents how many elements, and inside the data is essentially 2 million user ID who actually click the likes. That's how they represent. So just for your information, when I first crawled Facebook data to look at the JSON, this was from 2010, a single post from Facebook I download, the size of the JSON is pretty good, 20 megabytes. That's actually pretty big. So at that time, we have Occupy Davis, Occupy UC Davis. You probably heard about pepper spray. If you don't know that, you can check the Google. Very interesting happening on this campus. So at that time, there was a lot of emotion. Students are actually responding. And that's why I'm actually collecting all this JSON to see, try to do some kind of sentiment analysis. And that JSON is about 20 megabytes. By the time when Trump versus Clinton on that debate on Fox News, the second debate, one JSON, this was 2016, 2015, one JSON is about 2 gigabytes. Because you can imagine how many people click like, how many comments, and that's all using a simple JSON. I can actually represent that. And it's a huge amount of information. So I just want to tell you that this is really useful. On the other hand, it's actually quite simple. Okay. So just show you an example about this is when I talk JSON, I just show the representation. You can see that this is represents some kind of personal information. You can see there's a person, it's a first name, last name, as is alive, is a Boolean, and then age, address, and phone number. Phone number is an array because you might have multiple phone number. And then whether you have children, that's also an array. This is basically a Wikipedia when you actually look at a personality, a person's personal life or something like that, if that's available. Okay, so that's just example of JSON. Okay, so what I want to tell you is that there's a lot of programming support for JSON, but I want to my instruction instructional purpose today is just to teach you what JSON is, how simple it is in some sense. But I will also teach you the basic programming that you need to actually start writing JSON code. Okay. Okay. Any question about what I just said about JSON? Okay. I'm not going to go for this part. Okay, this is fine. Yeah, this part I just want to show you this one. This one is a Facebook-like post. You can see that we have a lot of ID, a lot of like and things like that. I'll just show you that it could be very complicated, but all the syntax is exactly the same. Bracket, double quote, colon, comma, and curly bracket. That's it. Everything represent everything you need. It's very amazing that with this few simple syntactic constructs that you can represent any information of an object-oriented language. Okay, so let's actually go back to look at the example. So now I want to go to person.h. So inside person.h, still the same, except I now have this dump to JSON. Instead of dump, now I said dump to JSON. That it is also returning a JSON colon value. Okay, I return that, but now I want to see how did I implement dump to JSON. Okay, this is a piece of code. I actually implement dump to JSON for person.h or person object. Let me make it a little bit bigger. Okay. So the same style. I create a blank JSON object result. It's a blank object without any argument. And then I start to do the name. I actually do a check. I said, is the name, is a string, is this an empty string? If it's an empty string, I'm not going to do the next line. So it's only if this, by the way, this is C syntax. If you're unfamiliar with C syntax, this means not equal. Okay, so this, if the name is actually not a null string, then I'm actually going to do this. How do I do that? Result, and then with the key. The key is a string, so basically I put the double quote there, says name, and then I put this name. And similarly, I'm actually doing this for SSN. Okay, that's name and the SSN. So now the rest is interesting. I'm going to call the GPS function for the dump to JSON function from GPS location. So what I did, you can see that I actually create a JV result. I create a blank JSON value called JV result. Then what I did is that I actually use this to the home. This to the home. What is the home? Home is GPS DD. This home to the dump to JSON. And then what's the return? Instead of return nothing, now I'm actually return a JSON value. That's why I create that local variable called JV result, which actually allow me to be able to put that result into this JV result. So now I have that JV result, which is actually contain the value from that GPS location. And then what I did, you see that I said result to the home is equal to JV result. So let me tell you that this is a little bit different because previously you can see I just put the string into this array, but now I'm actually putting it's an object. JV result is an object of the class JSON value. I actually just put the value into there. Okay, so JSON programming here is actually very flexible, very powerful because it can actually automatically detect what kind of data type you have, and then decide what's the right way to do it. So let's actually take a look, just compare SSM. SSM is a basic type of string. But here is JV result, is actually a result from calling home, the one level down, and then include that. So when you print it, you actually see the difference here. Let me actually show you. This is the output. You can see that if I print SSN, it just shows it's actually a 9-digit number. But when you say I want to print home, it's actually an object. And that object itself is a JSON. And therefore, it actually will show you this part. It's a JSON representation. Okay. And you can imagine that is just 2-level. But when your objects are getting more and more complicated, by calling down in this dump to JSON, you can actually get really the complete object this way. Okay. And similarly, you can get location. Let me actually just show you a little bit more. I have 8 minutes. Okay. And then you can actually see what I have is that the same thing, I do a location. And then I also do what? Since when? Since when is a JV time. It's a timestamp. I also call the dump to JSON to a time. So I can actually print out the time location. So basically, after I've done all this, so all my result has been put into this JSON object called result. And I just simply return the result. Can you give me one second? I want to show you the other piece of code. So now I'm actually going to the test function. Let me actually show you what I did here. So this is the same thing, just like I showed you last time. I create GPS location, I create a person, I create a meatball, and at the end, I set the location, and then look at what I did. I actually did this line to print out everything, because all I did is first I do say Felix.dump to JSON. This basically return me what? A JSON value. When I call that, it's actually not directly go to the standard output. It's actually giving me an object called a JSON object. So one of the function, if it's JSON object, then I have a bunch of tools I can do. One of the function that I'm going to be the first function I introduced to you is called toStyleString. So it actually helps you to format the JSON value in a pretty nice format, as I show you. That's called toStyleString. So you convert the JSON to the style string. Then I basically use cout to actually print it. That's why I showed you earlier. Okay, so that's how. And similarly, I did a Swedish meatball that dumped to JSON, and also to style string. So I actually dumped the meatball. I dumped Felix as well. Okay. Yeah. Question. Oh yeah, those two I should be more consistent, but they are actually equivalent. If I don't put curly braces, that means it's like a nothing. Nothing means no argument. So if I put a pair of curly brackets without anything, that means I'm going to trigger the constructor. Don't take any parameter, and if you don't put anything, that's also trigger the same constructor. Okay. All right. I just want to show you one more thing. I actually share with you this link. It's probably going to be too much for you at the moment, but this actually show you how powerful this library can do for you. And that is called JSON CPP library has let me just click on this one. You see this one, not this one. Wait a minute, I actually lost it. Yeah, here. So there's a link, I sent it to you together with the GitHub link. And that's the link about what we call JSON value class reference. And this actually gives you lots of information about all the function that you can call. For example, you can see that they have a lots of operator overloading, and you can actually use a function to actually test whether the value stored in the JSON, is this a string or is it an integer or is this a Boolean? So there's a lot of things you can actually test. So I just show you how to put it into a JSON. But the thing is that later you will learn how do you actually read something from the JSON. How about converting JSON back to C++? That's actually, by the way, homework number 3. How do you actually convert it back? When you convert it back, you actually better check whether that is an integer or is a string or is an array or is an object. It could be. You can actually. That's why you have the function like is null or is Boolean, is integer, is double, and then also has is array and also has is object. So you can actually check the value, what kind of type it is, to help your code to understand the JSON you're parsing. So this is actually some very useful resources. I usually come here, this is a single link, whenever I did JSON programming. In fact, in JSON programming, JSON value is probably the most frequently used resources you need. Okay. All right. So having said after 3 minutes, I want to introduce a little bit about homework assignment number 2. I just want to tell you what it is. So you can see what happened is that what I represent in this piece of code that I share with you today. You can see I have a person, I have a few location, I have a thing, which is a midball. So this is actually telling a story about somebody left home, go to a place called IKEA, and he actually purchased a product called Swedish meatball, and he probably, take it somewhere else. Okay, so you can think about this is actually a story. So we're talking about programming, we're talking about organizing information, but we're also talking about a story here. So how do you actually convert a story to object into programming? That's what I want you to do in homework assignment number 2. So homework assignment number 2 is actually, I call it Little Red Riding Hood. I assume you already know the story, right? The story could be complicated. I'm not talking about the movie version, which is the rabbit is a bad guy. That's not the version I'm talking about if you watch that movie. But I'm talking about the original one. So I actually quoted a bunch of story here. This is the first part of the story I actually quoted from that link above. And what I did is that I actually highlighted whatever the red part I highlighted, I actually want you to actually encode it into your program, your C++ program. So essentially, for example, the Little Red Riding Hood, of course, have a few person, has a girl, has her mother, her grandma, and by the way, the other person is the wolf. Okay, I treat wolf as a person. I use person to represent the wolf. And then there is a thing. There's a thing. What is a thing? Thing is the cake. The thing has the wine. The thing has his cat. Her cat is also a thing. And then there is a lot of GPS location here. Her grandma's home and her the place she actually met the wolf, and the place she actually got the cake and wine from her mother. So you can actually see there's a lot of things happening, which is you already know how to actually handle that. So what I ask you to do is that I want you to actually create a bunch of objects. By the way, you can create whatever object you want, C++, that's your choice. You feel free to take a look at the code I shared with you today or last week, so you can actually have a good idea about how you can do that. But you probably need to have those class. You probably need a person class. You need to have a thing class. Thing is a very generic way for you to represent anything you want. And then you probably need a GPS class. which you should know by now how to do that. And then you probably need the time I already give you. But the other thing you probably need is either we can call it event or record. So for example, when, where the Little Red Riding Hood first time met the wolf. That's actually included in the story. And I consider that is a record or is an event. So you can see that when we talk about the story from a programmer's perspective, it's just how do I represent each of the event with lots of person and thing and the time and GP location, put it together. So for your homework assignment number 2, what you need to do, you need to write program to show this 4 record or this 4 event. Let me just repeat very, very carefully. The first one is that Little Red Riding Hood wear her cap. And then there's an event, her mom is giving her the wine and the cake. And there's, by the way, all the event has a location, has a time, has a person, has a thing. And the third event is that she met the wolf at a particular spot. And also, grandma was actually at some location during that time when this happened. Okay, so by the way, the other thing is that this homework assignment is going to be 2-person project. So 2 students, I want you to discuss how best for you to actually represent the idea. I mean, you can read the homework assignment, you know why I want you have this too. And for the final project of this class, I'm actually going to have a 4 student on a team. So that's why I start to push you to know each other with this kind of homework. The other thing, very important for this homework assignment, every single class you define, you need to implement a function called dump to JSON. You need to implement dump to JSON. So at the end, how do I actually check your result? I just dump the JSON on this 4 event, which is supposed to give me everything I need. So essentially, I'll actually convert part of the Little Red Riding Hood to a bunch of JSON in this story. Okay. All right. I'm going to stop here. Let me stop recording first.